Welcome to the CAD Builder video tutorial series. In this video, we will take a look at how to create and configure a peanut joint connection construction in CAD Builder. The peanut connecting system uses a routed keyhole slot with an undercut and a matching connector. During assembly, the connector enters the slot and slides into the locking area, pulling the two parts together. CAD Builder supports Peanut 1, Peanut 2, and Peanut 3. The correct choice depends on whether the connector may remain visible and whether the shop can complete face machining only or also needs edge boring and connector insertion. Let's see how this works. Open Connection Constructions, and in the default folder, select the Peanut Joint template. Because the supplied template is read-only, use the copy icon to create an editable copy. Give the copied connection construction a name your shop will recognize, such as Peanut Joint. The first setting is Peanut Type. The available choices are Peanut 1, Peanut 2, and Peanut 3. Peanut 1 is the visible connector and is designed for a single face machining process on a suitable 3-axis CNC. An important distinction is that Peanut 1 does not require edge boring. All of its machining is completed from the face of the panel. Intelligent Fixing specifies a 5 mm hole made first, followed by a 24.9 mm or maximum 25 mm recess, along with the routed peanut slot. These are face machining operations used to recess and locate the connector. There are no separate Peanut 1 hole diameter fields in this connection construction, so verify the generated processing against the exact connector and tooling before production. Peanut 2 is an invisible, screw-secured connector. It uses the routed peanut slot on the face of one part and a 6 mm hole bored into the edge of the mating part. The connector is secured with a 3.5 mm or US number 6 screw. Glue is optional for a permanent assembly. Peanut 3 is an invisible pressed-in connector with teeth around its dowel end. It also uses the routed peanut slot on one part and a 6 mm edge hole in the mating part. Peanut 3 is secured with PVA wood glue and may be inserted manually or with compatible insertion equipment. Select the peanut type that matches the exact hardware and manufacturing process used by the shop. Changing peanut type also changes the peanut connector row to the corresponding Peanut 1, Peanut 2, or Peanut 3 hardware. Always verify that the connector shown still matches the selected type before saving. For this example, return to Peanut 1. Next is Invert Peanut Slot. The available choices are Not Inverted and Inverted. This setting reverses the direction of the routed locking slot and therefore changes the direction the mating part must slide during assembly. Use the diagram on the right and consider the complete cabinet assembly sequence. The selected direction must allow the parts to slide together without being blocked by another cabinet part. Peanut center's arrangement controls how the peanut connections are distributed along the joint. The available arrangements are front to rear, rear to front, and centered. Centered distributes the peanut centers evenly between the two ends of the joint. This is the arrangement shown in the supplied example. When centered is selected, CAD Builder displays the end peanut center position and peanut center quantity. End peanut center position can use exact distance or minimum distance. Exact distance places the outside peanut centers at the entered distance from both ends. Minimum distance treats the entered value as the smallest permitted end clearance, while CAD Builder distributes the pattern within the available joint length. For this example, we will keep this at exact distance and set it to 1.5 inches. Peanut center quantity can use quantity or spacing. Quantity tells CAD Builder how many peanut centers to place. The supplied example uses a quantity of 3. Spacing tells CAD Builder to distribute the centers using the entered center-to-center spacing. For this example, the spacing is set to 3 inches. Back up to the peanut centers arrangement. Front to rear starts the connection pattern from the front of the part and continues toward the rear. Rear to front starts the pattern from the rear and continues towards the front. With either directional arrangement, CAD Builder displays first peanut center position, peanut center spacing, and last peanut center minimum distance. First peanut center position controls the distance from the selected starting end to the first connection. Peanut center spacing controls the center-to-center distance between connections. Last peanut center minimum distance controls the minimum clearance that must remain between the final connection and the opposite end of the part. For this example, we'll keep the value at 1.5 inches from the first center, 2 inches for the spacing, and 1.5 inches for the last minimum distance. Choose the arrangement, end clearances, quantity, and spacing that match the joint length, connector requirements, and cabinet assembly sequence. For today, I will keep this set to centered. Parts gap adds an intentional space between the two connected parts. The supplied example uses 0 inches for a tight joint. Next is CNC. The available choices are CNC connection parts and no CNC connection parts. CNC connection parts tells CAD Builder to generate the supported machining for the peanut connection. No CNC connection parts leaves that machining out of the CNC output so it can be completed through another production process. This example is set to CNC connection parts. All peanut connector types require the dedicated T-shaped peanut cutter to create the keyhole slot and undercut. A standard straight router bit cannot create this locking profile. Confirm that the CNC setup and selected tool set reference the correct physical peanut cutter before generating production code. Intelligent Fixings lists 14,000 RPM as the recommended maximum for CNC use. Treat this as a maximum, not as a universal feed and speed setting. Use feed and plunge values that have been verified for the physical cutter, CNC machine, and material being processed. Peanut 1 is a face-only process. A suitable nested 3-axis CNC can create its routed slot and both recess holes in the same face machining operation. It does not require horizontal edge drilling. Peanut 2 and Peanut 3 require 2 types of processing: the routed slot on a panel face and the 6mm hole in the edge of the mating part. If the nested CNC does not support horizontal drilling, the edge hole must be completed with a separate edge boring operation, a peanut jig, or compatible drilling and insertion equipment. CAD Builder release notes identify support for Peanut 1, Peanut 2, and Peanut 3, along with integration for the OMO peanut insertion machine through generated CNC labels. For a shop using that workflow, verify that the required CNC label setup and machine integration are selected during manufacturing. The insertion machine stage is separate from the face routing operation performed during nesting. The final setting is Peanut Connector. The connector selector allows the matching peanut connector or no connectors. Select the connector that matches the peanut type so CAD Builder can include the correct hardware quantity and material cost in the materials list. Use no connectors only when the shop intentionally does not want that hardware included. After changing peanut type, verify this row again because CAD Builder updates it to the matching connector. Once the settings are complete, save the peanut joint connection construction. Next, open the construction method where the peanut connection will be used. Open the appropriate joint location and select the 3 dots on the far right to open the connection selector. For this demonstration, apply the peanut joint to a fixed shelf-to-side connection so the connector routed slot and assembly direction are easy to see. This is one practical end-to-face example and is not the only location where the connection may be used. Select Peanut Connection, choose the peanut joint you created and select it to apply the connection. Generate a test cabinet that uses this construction method and open the wireframe editor. Turn on Show Processing and Show Connectors as well, so the selected hardware can be inspected. Verify the selected peanut type and confirm that peanut connector matches it. Confirm the slot direction created by Invert Peanut Slot and make sure the cabinet can be assembled in that direction. Verify the center's arrangement, first or end position, spacing or quantity, last minimum distance when applicable, and parts gap. For Peanut 1, verify the routed slot and both connector recess holes on the panel face, and confirm that no edge bored hole is expected. For Peanut 2 or Peanut 3, verify the face routed slot and the matching 6mm edge bored hole, then identify which machine or production step will create each operation. If the pattern locks in the wrong direction, review Invert Peanut Slot. If the connections begin from the wrong end or are distributed incorrectly, review Peanut Center's arrangement and the placement field shown for that arrangement. If the wrong hardware appears or the quantity is missing from the materials list, review both peanut type and peanut connector. If a Peanut 2 or Peanut 3 job is missing its edge hole, confirm whether the selected CNC can perform horizontal drilling or whether the edge operation must be routed to separate equipment. Before releasing the setup for production, machine and assemble a physical test joint using the same connector, material, peanut cutter, tool set, and equipment planned for the job. Confirm that the connector installs correctly, the parts slide together in the intended direction, the self-clamping action pulls the joint tight, and the completed cabinet can be assembled in the planned sequence. As you can see, Cab Builder allows you to select Peanut 1, Peanut 2, or Peanut 3, control the locking direction and connection pattern, include the matching connector in the materials list, and generate the supported machining for the shop workflow. Thank you for watching, and we will see you in the next video. For more video tutorials, please visit our website at www.cabbuildersoftware.com/training. Thank you.